The universe has a way of keeping secrets, but rarely do these secrets arrive at our doorstep with the weight and precision of 3I/Atlas. From the moment this enigmatic object was detected hurtling through the void, astronomers, scientists, and even casual skywatchers felt a shiver of unease, a visceral recognition that something was profoundly unusual. 3I/Atlas did not announce itself with the predictable signatures of a comet or asteroid. It moved differently, behaved differently, and seemed to carry with it an aura of deliberate intent. This is why the world is hooked from the start, why attention has been riveted, and why the questions it raises refuse to be ignored. Every telescope turned skyward seemed to capture not merely light or trajectory, but a whisper of the unknown, a suggestion that humanity was witnessing a phenomenon far more complex than any ordinary space rock. Scientists have tirelessly mapped its path, yet every discovery seems to deepen the mystery. What is it? Where did it come from? And most chillingly, could there be a hidden mission embedded in its trajectory? Something that reaches beyond mere observation into the realm of deliberate interstellar strategy? The more data collected, the less certain the answers become, and the more the enigma of 3I/Atlas swells into something almost palpable, a presence that dominates headlines and ignites whispered conversations in laboratories and observatories alike. To grasp the implications, one must confront not only the technical oddities of its orbit and behavior, but also the psychological impact of encountering an intelligence or force that operates on scales and intentions beyond our comprehension. 3I/Atlas is more than an object. It is a puzzle that challenges humanity's understanding of the cosmos and, in doing so, demands attention, respect, and perhaps even a measure of fear. This deep dive into its hidden mission begins here, with the world watching, wondering, and holding its breath. The discovery of 3I/Atlas was not a quiet event. It began with the subtle flicker of an unremarkable blip on the digital feed of automated sky surveys. Initially, only a handful of astronomers noticed it, a faint, fast-moving object that did not conform to the catalogued movements of known celestial bodies. On the evening it first appeared in the field of the Asteroid Terrestrial Impact Last Alert System, ATLAS, a network designed to detect potentially hazardous asteroids. The automated alerts triggered curiosity rather than alarm. Observers noted the unusual speed of its approach, the stark contrast against the star field, and the lack of a recognizable cometary tail or reflection pattern consistent with solar system debris. It was, in essence, something that should not have been there. Within hours, the anomaly spread through professional astronomical circles. Data was analyzed, reanalyzed, and subjected to peer scrutiny. The initial consensus suggested a rogue interstellar object, similar perhaps to Oumuamua, yet several key differences were immediately apparent. Unlike previous interstellar visitors, this object displayed an irregular rotation and a trajectory that hinted at deliberate alteration rather than simple gravitational drift. Its approach vector did not align with the galactic tide or any natural perturbation. Instead, it seemed almost precise, as though it had a destination in mind. This subtlety electrified astronomers, many of whom had spent decades cataloging asteroids and comets, now facing a phenomenon that defied classification. Word of the discovery leaked to the public quickly, feeding a growing fascination that merged scientific excitement with a cultural obsession for the unknown. News outlets ran headlines emphasizing the potential implications. Mysterious interstellar object approaches Earth. Is this the first sign of extraterrestrial intelligence? Social media platforms exploded with speculation, and forums filled with amateur astronomers sharing sightings, calculations, and theories. Public fascination was fueled not only by the novelty but by the fear of the unknown. The object's trajectory suggested proximity to Earth's orbit in the months ahead, giving the sensation of an imminent encounter and heightening both intrigue and anxiety. Among professional astronomers, reactions were a mix of cautious excitement and analytical rigor. Teams from NASA, the European Space Agency, and various university observatories began prioritizing observations, pooling resources to capture high-resolution images and spectrographic data. Researchers sought to understand its composition, spin, and trajectory, using the full arsenal of modern astrophysical instrumentation. The first anomaly noted was its light curve, which varied in ways inconsistent with simple tumbling. The brightness oscillated irregularly, suggesting reflective or surface properties that no natural object of its size should possess. This subtle, almost imperceptible irregularity marked the first hint that 3I/Atlas might not be just another interstellar wanderer. Conspiracy theorists were, predictably, quicker to assign sinister or extraordinary explanations. Online communities speculated that the object was an alien probe, a covert weapon, or a precursor to an interstellar visitation. Some linked it to ancient prophecies or secret government projects, weaving elaborate narratives supported by cherry-picked observations and misinterpreted data. While mainstream science largely dismissed these theories, the sheer volume of public interest created a cultural feedback loop. The more people debated the object's origin, the more media coverage it received, and the more intense the fascination became. In this sense, the discovery of 3I/Atlas was not just an astronomical event. It was a socio-cultural phenomenon, highlighting humanity's dual desires for knowledge and awe. As observations continued, several anomalous behaviors became increasingly apparent, further fueling both scientific scrutiny and public speculation. Unlike typical comets or asteroids, which follow predictable orbital paths, 3I/Atlas displayed minor but measurable deviations that could not be immediately explained by gravitational interactions with known bodies. These deviations, though subtle, suggested either an unknown physical property, perhaps outgassing or a previously unseen propulsion mechanism, or, more provocatively, deliberate manipulation of its trajectory. The implications were staggering. A natural object of this kind should obey Newtonian physics with near-perfect predictability, yet here was a celestial body behaving as though it had a hidden agenda. International observatories began to coordinate around-the-clock monitoring. Radio telescopes scanned for signals, while optical instruments captured its rotation and shape. Each new data point added layers of intrigue. Scientists noticed spectral anomalies, reflecting unusual surface composition not seen in natural asteroids or comets. This observation sparked debates within the astrophysical community. Were these anomalies a result of exposure to interstellar environments, or did they suggest artificial construction? The sheer novelty of these behaviors meant that no existing models fully accounted for them, forcing researchers to consider previously dismissed scenarios. Public fascination intensified alongside the scientific intrigue. Documentaries, news specials, and online deep dives proliferated, portraying 3I/Atlas as both a cosmic wonder and a potential harbinger of change. Social media amplified individual sightings and amateur observations, creating a decentralized network of citizen astronomers whose real-time reports often rivaled professional data in quantity, if not in precision. The cultural impact was profound. Suddenly, the sky was not a distant, unapproachable domain, but a theater for a story that could touch everyone on Earth. Schools, universities, and museums reported a surge in interest in astronomy, physics, and space exploration. The object had become a magnet for imagination, a symbol of humanity's longing for connection to the cosmos, and simultaneously, a reminder of our vulnerability when confronted with the unknown. Amid this swirling mix of excitement and fear, the scientific community issued careful statements, balancing the need for public information with the caution of incomplete data. Initial press releases emphasized observable facts: the object's speed, trajectory, and irregular brightness patterns. They deliberately avoided speculation on its origin, but the choice of language, phrases like anomalous behavior and unprecedented features, was enough to stoke curiosity and unease. The subtle tension between transparency and restraint created a fertile ground for rumor and speculation, and even within academic circles, discussions took on a sense of urgency rarely associated with the observation of a distant object. By the end of the initial observation period, 3I/Atlas had firmly embedded itself in both scientific and public consciousness. It was no longer simply another celestial body. It was a mystery demanding attention, debate, and intense scrutiny. Every telescope aimed at it, every model constructed to predict its behavior, and every hypothesis proposed about its nature fed into a growing narrative of cosmic uncertainty. Fear, fascination, and curiosity intertwined, creating a unique environment in which the object's movements were analyzed with the intensity normally reserved for events threatening human survival. The first anomalous behaviors, the irregular brightness, trajectory deviations, and spectral oddities, were no longer minor footnotes. They became the foundation upon which future speculation, investigation, and even controversy would be built. The discovery of 3I/Atlas exemplified a rare convergence of scientific opportunity and cultural resonance. It was not just the technical challenge of observing an interstellar visitor. It was the realization that something profoundly strange had entered the sphere of human attention, forcing both experts and the general public to confront questions about the limits of knowledge, the potential for intelligence beyond Earth, and the mysteries of the cosmos that remain tantalizingly beyond reach. From the first detection to the initial flurry of observations, the world had collectively held its breath, captivated by an enigma that refused to fit into familiar categories. In retrospect, the initial reactions to 3I/Atlas set the tone for all subsequent investigations. The mix of excitement, caution, and fear established a narrative framework in which the object's very presence demanded a re-evaluation of assumptions, both scientific and cultural. The timeline of its observation, the first blip on automated feeds, the rapid international coordination, the anomalies detected in trajectory and composition, formed the backbone of an unfolding story that would challenge humanity's understanding of the universe. Each reaction, from the measured statements of astronomers to the speculative frenzy of online theorists, contributed to a sense that something larger, more deliberate, and perhaps more unsettling was at play. The world had witnessed the first chapter of a story that was only beginning to unfold. 3I/Atlas was no longer a distant curiosity. It had become a symbol of cosmic mystery, an object of scientific scrutiny, and a catalyst for cultural reflection. Its discovery and the reactions it provoked laid the groundwork for everything that would follow. Deeper investigation, international collaboration, and the persistent question that would echo across observatories, laboratories, and living rooms alike. What truly is 3I/Atlas, and why is it here? Following the initial excitement surrounding its discovery, astronomers quickly turned their attention to the behavior of 3I/Atlas, seeking to understand how this interstellar visitor moved, rotated, and reflected light. Unlike ordinary asteroids or comets, which can be predicted with relative certainty once initial data is collected, 3I/Atlas refused to conform to any established model. Its trajectory, though broadly aligned with expectations for an object entering the solar system, contained subtle deviations that intrigued and unsettled researchers. These deviations were small, fractions of a degree in calculated orbit, but consistent enough to suggest that they were not random. They sparked questions that went beyond physics, hinting at the possibility that this object might not simply be drifting through space by chance. When compared with Oumuamua, the first confirmed interstellar object detected in 2017, the differences became even more pronounced. Oumuamua had already baffled astronomers with its elongated shape, rapid rotation, and unexpected acceleration, which some attributed to outgassing. In contrast, 3I/Atlas displayed behavior that was even more enigmatic. Its spin pattern was irregular, with periods of acceleration and deceleration that could not be fully explained by solar radiation pressure or gravitational influences from nearby planets. The brightness oscillations were equally perplexing, fluctuating in a manner that suggested a reflective surface with inconsistent angles or perhaps internal structural complexity. The very nature of these observations prompted a wave of meticulous analysis, with astrophysicists scrutinizing every pixel of imaging data, every light curve, and every radar reflection for signs of underlying structure or purpose. In addition to its irregular motion, 3I/Atlas presented spectral anomalies that only deepened the mystery. Spectroscopy, a tool that allows scientists to determine composition based on the light an object emits or reflects, revealed a chemical signature unlike typical asteroids or comets. There were traces of metals and organic compounds, but in ratios and distributions that did not match known solar system materials. Some elements appeared concentrated in discrete regions, suggesting either a heterogeneous natural formation or, more provocatively, deliberate construction. These findings, initially approached with caution, began to hint at the possibility that 3I/Atlas was not a naturally occurring object, or at least that some aspects of its formation or structure were influenced by unknown forces or technologies. the object's trajectory offered further intrigue. Entering the solar system at a high velocity, 3I/Atlas passed close to the plane of the planets, yet it avoided any clear gravitational capture or deflection, moving with an uncanny precision that left even seasoned orbital mechanics experts scratching their heads. Its path intersected regions of space where planetary observation stations were concentrated, almost as if it were aware of monitoring efforts, an impression that, while scientifically speculative, became hard to ignore given the consistency of its unusual route. Even minor perturbations seemed calculated to maximize observation opportunities while minimizing the risk of collision with known bodies, reinforcing the idea that this interstellar visitor was not merely a passive traveler but could be operating under intentional parameters. Radio and electromagnetic monitoring yielded yet more subtle anomalies. While no explicit signal was detected, researchers noted faint and intermittent variations in the electromagnetic spectrum surrounding the object. These fluctuations were not consistent with typical cosmic background noise or solar emissions, leaving open the possibility of non-random activity. Some scientists hypothesized that these could be naturally induced phenomena, perhaps plasma interactions or charged particle emissions, but others argued that the pattern suggested a form of communication or active energy modulation, however primitive or subtle. The ambiguity only increased the object's mystique, straddling the line between natural and potentially engineered phenomena, and reinforcing the notion that further observation was essential. The combination of these irregularities, trajectory deviations, rotational anomalies, spectral oddities, and subtle electromagnetic activity set 3I/Atlas apart not only from Oumuamua but from any known interstellar visitor. Researchers began to explore scenarios that went beyond conventional explanations, including the theoretical possibility of an engineered probe, a reconnaissance device, or even a delivery mechanism for some unknown payload. While such ideas remained speculative and were treated cautiously in academic circles, the sheer accumulation of unexplained characteristics created an atmosphere in which more extraordinary explanations could no longer be entirely dismissed. Every dataset was cross-referenced, every curve double-checked, and yet the same questions persisted. How, why, and with what purpose did this object behave as it did? Subtle features in the light curve provided additional hints of complexity. Unlike ordinary tumbling asteroids, whose rotation produces predictable periodic changes in brightness, 3I/Atlas displayed asymmetric fluctuations. Some peaks in luminosity appeared sharper than expected, while others lingered, suggesting reflective surfaces of different orientations or even hollow sections within its structure. Researchers postulated that these anomalies could indicate non-uniform material distribution, possibly suggesting artificial internal compartments, though confirming such a hypothesis would be impossible without a close-range inspection. Nevertheless, the pattern reinforced the sense that the object's behavior was not entirely random, and the notion of a hidden purpose began to emerge as a plausible, if still unproven, interpretation. The discussion extended beyond purely physical observations. Psychologically, the repeated irregularities and subtle defiance of expectation had a profound effect on both scientists and the public. Observers reported a sense of intent behind the object's movement, a feeling reinforced by the human tendency to ascribe agency to patterns that resist straightforward explanation. In laboratories and observatories worldwide, teams debated not only the mechanics of the object but also its potential implications, often finding themselves returning to the question of design versus coincidence. Each new observation, no matter how minor, seemed to accentuate the impression that 3I/Atlas was operating with a level of sophistication and forethought that transcended natural stochastic processes. Comparisons with other anomalous interstellar events became central to understanding the object. Oumuamua's behavior had been exceptional yet explainable within certain limits of physics, but 3I/Atlas consistently exceeded those bounds. While both objects entered the solar system at high velocities, 3I/Atlas's deviations and surface heterogeneity were more pronounced, as if it carried both the complexity of a natural formation and the subtlety of engineered design. The combination of these factors prompted some researchers to adopt hybrid models, where natural formation could be influenced or modified by unknown processes, creating an object that straddled the line between celestial phenomenon and engineered artifact. As months of observation accumulated, the anomalies became increasingly difficult to ignore. Precise measurements indicated that rotational acceleration was sometimes anticorrelated with solar pressure, defying the expected behavior of a body moving through sunlight. Minor alterations in trajectory also seemed to coincide with areas of dense observation, reinforcing the notion that the object might be aware of human monitoring. While entirely speculative, the mere possibility of intelligent influence prompted heightened scrutiny, leading to the allocation of additional telescope time, international collaboration, and the launch of specialized observation campaigns designed to detect even the faintest sign of directed activity. Throughout this period, the subtle suggestion of mission-driven purpose became a recurring theme in both scientific papers and popular discourse. Researchers cautiously framed these interpretations as possibilities rather than conclusions, emphasizing that no definitive evidence of intelligence existed. Yet, the accumulation of deviations, patterns, and anomalies created a narrative that was hard to dismiss. 3I/Atlas was behaving in ways that suggested a function beyond mere random traversal. Its trajectory, composition, rotation, and spectral properties collectively hinted at the presence of a guiding principle, a hidden design, or a deliberate mission embedded within its interstellar journey. This growing sense of purpose did not remain confined to technical discussions. Media outlets, documentaries, and online forums began to explore the idea that the object could be more than a natural visitor, popularizing the notion of a probe or emissary sent from another star system. While mainstream scientists continued to emphasize caution and the need for further data, the public imagination had been captured, creating a feedback loop in which speculation drove attention, which in turn motivated additional observation and research. The strange behavior of 3I/Atlas had become both a scientific puzzle and a cultural touchstone, illustrating the profound impact that anomalous phenomena can have when they resist easy categorization. As observation campaigns intensified, each new dataset reinforced the complexity and irregularity of the object. High-resolution imagery suggested surface features inconsistent with natural erosion or impact cratering, while spectroscopy continued to reveal unexpected chemical heterogeneity. Electromagnetic variations persisted without a clear natural source, challenging assumptions about how objects in interstellar space interact with ambient fields. Taken together, these elements constructed a picture of an entity that was both familiar and alien, obeying the laws of physics while simultaneously hinting at knowledge and behavior that transcended ordinary celestial mechanics. Ultimately, the strange behavior of 3I/Atlas set the stage for deeper investigation and speculation. Its trajectory, spin, composition, and spectral anomalies created a sense of suspense, suggesting that more lay beneath the surface than initially perceived. By comparison with known interstellar objects and through meticulous observation, it became clear that the object could not be fully explained by conventional models. The possibility of deliberate design, hidden purpose, or even a mission-driven objective emerged as a legitimate question, not confirmed, but impossible to ignore. Each anomaly added weight to this hypothesis, reinforcing the sense that humanity was witnessing not just a visitor from beyond the stars, but a phenomenon that challenged understanding and hinted at intention. As the strange behavior of 3I/Atlas became increasingly evident, a parallel narrative began to emerge, one that was less about physics and more about secrecy. While public-facing scientific reports carefully documented anomalous trajectories, spectral irregularities, and rotational deviations, a quieter story unfolded behind the scenes. Observatories, research institutions, and even individual astronomers began noticing patterns of communication and data release that seemed deliberately structured to downplay or obscure the most perplexing aspects of the object. In some cases, datasets were delayed, key observations remained unpublished, and certain anomalies were mentioned only in footnotes, sparking speculation that official channels were intentionally withholding information. Leaked reports, while fragmentary and often unverifiable, added fuel to this growing suspicion. Anonymous sources from within space agencies suggested that early measurements of 3I/Atlas included details that could radically alter the understanding of its nature. Some of these leaks referenced unusual surface geometries, electromagnetic anomalies, and trajectory deviations that implied intelligent influence. Though none of these claims could be independently confirmed, the mere existence of such reports lent an air of conspiracy to an already mysterious object. Media outlets covering the leaks carefully walked a line, presenting them as unconfirmed but significant, ensuring that public curiosity and anxiety remained heightened. The subtle manipulation of information extended beyond selective reporting. Press briefings by agencies such as NASA and the European Space Agency often emphasized routine measurements and minimized anomalies, framing irregularities as minor deviations that were within expected margins. Scientists who spoke publicly were sometimes cautious in their language, employing technical terms that downplayed the object's strange behavior without denying it outright. Meanwhile, internal communications, later leaked or partially revealed, suggested that certain teams were instructed to prioritize standard observation procedures, while more sensitive findings were classified or shared only with a small circle of specialists. This dichotomy between transparency and secrecy created a sense that the public narrative was carefully curated, with the most unnerving implications intentionally obscured. Tensions between scientific openness and classified agendas became particularly evident when international collaborations were examined. Some observatories reported difficulty obtaining complete datasets from partner institutions, citing bureaucratic or legal restrictions that seemed unusual in a field typically characterized by data sharing. In other instances, attempts to publish anomalous findings in peer-reviewed journals were met with delays or requests for additional review by governmental bodies, suggesting that even scientific publishing was influenced by external oversight. For researchers accustomed to open debate and rigorous peer evaluation, these interventions were both frustrating and alarming, hinting at a level of oversight rarely associated with celestial observations. The tone of secrecy extended into the media, where coverage was often shaped by subtle cues rather than outright statements. Headlines emphasized curiosity, intrigue, or technological achievement, while minimizing the more disquieting aspects of the object's behavior. Articles would note the unusual trajectory or spectral anomalies, but immediately follow with reassurances that these were likely natural or within expected ranges. Even social media accounts affiliated with official agencies participated in shaping perception, posting selectively curated images and data to emphasize ordinary motion while omitting evidence of rotational or electromagnetic irregularities. The cumulative effect was to present 3I/Atlas as a scientific curiosity rather than a potential anomaly of extraordinary significance. Yet, despite these efforts, cracks in the facade were apparent. Amateur astronomers, independent researchers, and investigative journalists pieced together evidence that suggested a more complex reality. Observations shared in forums and online communities often contradicted official narratives, highlighting anomalies that were ignored or downplayed in public reports. Cross-referencing multiple datasets revealed inconsistencies in reported brightness, trajectory, and rotation, feeding the perception that information was being selectively controlled. In some cases, attempts to reconcile these discrepancies with official explanations only deepen the mystery, suggesting that deliberate obfuscation, rather than simple error, might be at play. The implications of these cover-ups were profound, extending beyond the scientific community into the realm of geopolitics. The fact that multiple nations maintained high-level observation campaigns but selectively limited data sharing hinted at a broader strategy, protecting sensitive information while managing public perception. Some analysts speculated that governments were aware of aspects of 3I/Atlas's behavior that could be unsettling if widely disclosed, and that secrecy was intended to allow time for analysis, contingency planning, or even communication strategies. The tension between disclosure and concealment created an atmosphere of suspicion, in which every official statement was scrutinized for hidden meaning, every delay questioned, and every omission considered significant. Leaked statements from unnamed insiders reinforced this perception of deliberate concealment. Some claimed that early readings suggested 3I/Atlas possessed properties inconsistent with any natural formation, potentially indicative of artificial origin. Others described internal debates over how or whether to inform the public, reflecting the inherent conflict between scientific transparency and national security considerations. Even when these statements were only partially verified, they fed a narrative in which the object was not just a passive celestial visitor but a phenomenon whose full significance was being carefully controlled, analyzed, and, in some cases, withheld. Conspiracy theorists and independent researchers seized upon these gaps with vigor. Forums and online platforms became repositories for speculation, where leaked documents, anomalous measurements, and inconsistencies were compiled and dissected. While mainstream science cautioned against drawing conclusions from incomplete or unverified data, the sheer volume of anomalies and selective reporting created a fertile ground for alternative explanations. The discussion ranged from plausible scenarios involving experimental propulsion or interstellar monitoring devices to more extraordinary ideas of intentional visitation or surveillance, reflecting both the complexity of the evidence and the human tendency to seek meaning in uncertainty. Internal debates within agencies also revealed a philosophical tension: the desire to maintain scientific credibility versus the perceived necessity of strategic discretion. Some researchers advocated for complete transparency, arguing that public scrutiny and peer review were essential for validating findings and avoiding misinterpretation. Others contended that premature disclosure of anomalies could incite panic, misinform the public, or inadvertently reveal sensitive capabilities related to observation technology. These debates highlighted the delicate balance between openness and control, underscoring the unique position of 3I/Atlas as an object whose very existence challenged norms of scientific communication. Even outside formal institutions, the shadow of potential concealment influenced interpretation. Observers noticed that certain high-resolution images or spectrographic datasets were only partially released, with key frames or segments omitted. In some cases, technical limitations were cited, but cross-referencing with other sources suggested that some omissions might have been deliberate. Analysts noted patterns in timing, framing, and release that seemed designed to minimize the visibility of rotational anomalies, trajectory deviations, or electromagnetic fluctuations, subtly shaping the narrative to favor conventional interpretations over more extraordinary possibilities. The overall effect of these maneuvers was a complex landscape in which truth and perception became entangled. Official statements, partial leaks, and curated media coverage created layers of narrative, some transparent and verifiable, others opaque and speculative. For the public, the result was fascination tinged with unease, an awareness that while scientists were observing and analyzing the object, much of what might be most consequential was being withheld. Within professional circles, the tension between transparency and classified oversight generated both frustration and cautious optimism, with researchers striving to extract maximum insight from limited data while recognizing that some dimensions of the phenomenon were likely inaccessible without extraordinary disclosure. By the end of this period of initial observation and partial revelation, it had become clear that 3I/Atlas was not only unusual in its physical behavior but also in the social, institutional, and political dynamics it provoked. The combination of leaked reports, delayed or partial data, media framing, and internal debates suggested a coordinated effort to manage perception while maintaining analytical advantage. Scientists, journalists, and independent observers alike began to see that the story of 3I/Atlas extended beyond astronomy, touching upon questions of secrecy, strategic communication, and the tension between knowledge and control. In essence, the object's strangeness was mirrored by the strangeness of human response, a layered mixture of disclosure and concealment, observation and restriction, curiosity and caution. Every anomaly in trajectory, rotation, or electromagnetic activity was compounded by questions of what was being shown, what was being withheld, and why. In this environment, suspicion became as important as measurement, interpretation as critical as observation, and narrative management as consequential as raw data. The result was a heightened sense of intrigue and foreboding, reinforcing the idea that 3I/Atlas was not merely an object to study but a phenomenon that challenged both understanding and governance. The interplay between scientific rigor and strategic secrecy ultimately intensified the object's aura of mystery. Researchers had to navigate official constraints, carefully interpret incomplete datasets, and contend with public speculation fueled by selective leaks. In doing so, they were forced to acknowledge that the full scope of 3I/Atlas's significance might never be fully revealed in the conventional channels of scientific discourse. Meanwhile, public perception, shaped by both curiosity and suspicion, continued to escalate, feeding a narrative in which the object's unusual behavior and the apparent concealment of critical information became inseparable. The story of 3I/Atlas, therefore, was no longer just about an interstellar object with anomalous properties. It had become a tale of human reaction, institutional strategy, and the tension between transparency and secrecy. The object's existence forced a confrontation with uncomfortable questions. How much do governments and institutions know? What are they withholding? And for what purpose? In exploring these questions, the narrative surrounding 3I/Atlas shifted from mere astronomical curiosity to a profound investigation into the dynamics of knowledge, control, and the unknown. The unusual behavior, irregular trajectory, and spectral anomalies of 3I/Atlas, researchers and theorists alike began contemplating a possibility that had long lingered on the fringes of scientific discourse. Could this object be a probe or artifact from an advanced civilization? The thought was simultaneously exhilarating and unnerving. While mainstream astrophysics emphasizes natural explanations first, the accumulation of anomalies, trajectory deviations, rotational irregularities, electromagnetic fluctuations, and surface heterogeneity made it increasingly difficult to dismiss the notion entirely. The very characteristics that set 3I/Atlas apart from typical interstellar objects opened the door to a hypothesis that had, until now, remained largely theoretical. Among the first aspects considered was propulsion. Unlike ordinary asteroids, which move predictably under the influence of gravity and radiation pressure, 3I/Atlas exhibited subtle but measurable deviations that could not be fully explained by solar wind or gravitational perturbations alone. While some scientists proposed unconventional natural explanations, such as asymmetric outgassing of volatile materials, others noted that the precision and timing of these deviations were remarkably consistent, almost as if the object were subtly adjusting its course. The idea of controlled propulsion, even at an incredibly low scale, raised the tantalizing possibility of intelligent design. A self-guided probe navigating the vast distances between star systems with extraordinary precision. Equally provocative was the object's shape and rotation. High-resolution imaging and light curve analysis suggested a geometry that did not conform to typical interstellar rock. Some peaks in brightness, sharp and uneven, indicated facets or surfaces oriented at unusual angles, while prolonged low-intensity reflections hinted at hollow or irregular internal structure. The rotation, far from a simple tumbling motion, followed an irregular pattern that sometimes appeared synchronized with orbital positioning relative to the Sun. While natural explanations such as non-uniform density and irregular shape could account for some variations, the complexity of the motion and its correlation with trajectory deviations invited speculation about deliberate stabilization or attitude control mechanisms, technologies one might expect from an intelligent probe rather than a passive rock. Reflective properties offered another intriguing clue. Spectroscopy revealed alternating regions of high reflectivity and subdued brightness, inconsistent with known asteroid compositions. Certain sections appeared unusually smooth or metallic, while others contained spectral signatures suggestive of organic compounds or composite materials unknown in solar system bodies. Some theorists proposed that these alternating properties could serve functional purposes. For instance, aiding thermal regulation, assisting in propulsion via solar radiation, or even acting as optical signaling. In combination with the rotational and trajectory anomalies, these reflective characteristics lent credence to the notion that 3I/Atlas could be engineered, rather than simply a naturally occurring interstellar artifact. The cumulative weight of these anomalies prompted a spectrum of scientific and speculative responses. Within mainstream astrophysics, researchers maintained cautious skepticism, emphasizing that extraordinary claims require extraordinary evidence. Yet even cautious analyses began to consider hybrid models, natural formation altered by unknown processes, or natural objects repurposed by technological intervention. These models allowed room for possibilities that straddled natural and artificial origins, acknowledging that our current understanding of interstellar phenomena might not account for all forms of complexity. Peer-reviewed discussions raised questions about the limits of natural explanations, particularly given the precision and subtlety of 3I/Atlas's behaviors. Meanwhile, fringe hypotheses flourished outside conventional scientific channels. Enthusiasts, independent researchers, and theorists explored ideas ranging from alien reconnaissance to interstellar messaging. Some posited that 3I/Atlas could be an emissary from an advanced civilization, designed to observe, record, or even communicate across vast distances. Others suggested it might be a technological seed, intended to monitor planetary systems or transmit data back to its origin. While these scenarios lacked empirical proof, The combination of anomalies in motion, composition, and reflection created a context in which such ideas were not entirely implausible. The object's unpredictability, after all, was itself suggestive of sophistication beyond the purely natural. Propulsion theories ranged from the conventional to the extraordinary. Solar radiation pressure, a force capable of subtly nudging small objects, could account for some deviations, but not the full extent of 3I/Atlas's trajectory adjustments. Hypothetical onboard mechanisms, such as microthrusters, electrostatic sails, or other advanced technologies, were considered. While none of these could be directly observed, the mathematical modeling of trajectory deviations suggested controlled adjustments that aligned with observational goals, reinforcing the notion of mission-directed movement. Even the possibility of a hybrid propulsion system, part natural, part engineered, was seriously entertained, illustrating how the boundaries between conventional astrophysics and speculative engineering were being tested. Shape and structural analyses reinforced the probe hypothesis. Observed variations in brightness indicated non-uniform surfaces and facets that could functionally support a mission. Reflective panels for solar energy collection, sensors embedded in smooth surfaces, or cavities designed to reduce mass while maintaining structural integrity. The irregular rotation suggested that these surfaces were intentionally oriented at certain intervals, perhaps to optimize observation or navigation. These subtle design features, while speculative, were consistent with the behaviors one might expect from an interstellar probe engineered for endurance and adaptability across light years of travel. Spectral data continued to provoke intense debate. Regions with unusual chemical compositions suggested the presence of materials resistant to cosmic radiation or capable of withstanding extreme thermal fluctuations. In addition, localized concentrations of metals or compounds implied either a heterogeneous natural formation or deliberate assembly. Scientists speculated that such distributions could serve functional purposes, shielding sensitive components, modulating heat, or facilitating communication. Though these interpretations remained unproven, they highlighted the degree to which 3I/Atlas challenged conventional assumptions about interstellar object composition. The question of intelligence extended beyond physical properties to the possibility of a mission or directive. Some theorists proposed that subtle anomalies, trajectory deviations, orientation changes, reflective modulation, could constitute a form of purposeful behavior. If true, the implications were staggering. Humanity might be observing a deliberate intervention, whether observational, communicative, or experimental. The possibility of an intelligence embedded within a celestial object forced a reconsideration of interstellar detection methods and our assumptions about the capabilities of advanced civilizations. The object, in essence, became a potential message in motion, a puzzle demanding both analytical and imaginative engagement. Scientific skepticism, however, remained a crucial counterbalance. Mainstream astrophysicists emphasized that apparent anomalies could still arise from unknown natural processes. Non-uniform outgassing, magnetic interactions, or previously unobserved cosmic forces might explain deviations without invoking intelligence. Yet the convergence of multiple anomalies, rotation, trajectory, reflection, spectral composition, created a scenario in which natural explanations appeared increasingly strained. The scientific community, therefore, found itself in a delicate position, acknowledging uncertainty while rigorously testing every conceivable hypothesis, including those that hinted at artificiality. Public fascination mirrored the scientific tension. Popular media, online forums, and independent commentators speculated widely about the nature of 3I/Atlas. Some embraced the notion of a probe, proposing that it could be humanity's first encounter with extraterrestrial technology. Others suggested that the object represented a broader class of interstellar engineering, a sign that advanced civilizations might routinely send durable, intelligent probes across the galaxy. While much of this discussion veered into the speculative, it reflected the broader impact of the anomalies. A convergence of scientific inquiry and cultural imagination, each feeding the other in a dynamic feedback loop. Debates over potential purpose further intensified scrutiny. If 3I/Atlas were indeed a probe, what might its mission be? Some suggested reconnaissance, gathering data on planetary systems before transmitting back to its origin. Others proposed communication, using reflective modulation or trajectory adjustments as a form of signaling. Some more speculative ideas included experimental seeding, deliberate deployment of materials, microorganisms, or information designed to propagate or study ecosystems across interstellar distances. While these scenarios remain theoretical, the object's complex behavior allowed space for their consideration, highlighting the profound ambiguity inherent in observing a potentially intelligent artifact from afar. Ultimately, the hypothesis of alien technology did not exist in isolation. It intersected with ongoing investigations into the object's anomalies, the secrecy surrounding its observations, and the broader cultural and scientific discourse. The combination of observed irregularities, careful speculation, and incomplete disclosure created a context in which the probe hypothesis could be seriously entertained, even if it remained unproven. Each new dataset, from rotational measurements to spectral analysis, reinforced the tension between conventional astrophysics and the possibility of deliberate, intelligent design. In considering 3I/Atlas as a probe, it became clear that traditional frameworks were insufficient. The object challenged assumptions about interstellar dynamics, material composition, and natural formation processes. It prompted a reconsideration of what constitutes evidence, how subtle patterns are interpreted, and how to distinguish between randomness and purpose across interstellar distances. In effect, the object became a laboratory not just for physics, but for the philosophy of observation itself. How to assess intelligence, design, and intent in a context where direct interaction is impossible and measurement is constrained by distance and instrumentation. By the conclusion of this phase of observation, the notion that 3I/Atlas might be an artificial probe had entered serious scientific discourse alongside natural explanations. While no definitive proof of intelligent origin existed, the convergence of anomalies created a framework in which directed purpose, advanced engineering, and mission-driven behavior could no longer be dismissed outright. It was, in every sense, a challenge to both imagination and rigor, demanding that scientists, theorists, and the public alike reconsider the boundaries of what was possible in interstellar exploration. The enigmatic behavior and potential intelligence suggested by 3I/Atlas naturally drew comparisons with historical astronomical events that had captured human attention and imagination. For millennia, the sky has served as both a laboratory and a canvas for interpretation, with celestial phenomena inspiring awe, fear, and prophecy. Across cultures and eras, unusual objects in the sky, comets, supernovae, and other interstellar visitors, were often interpreted as omens, heralds of change, or signs of divine intervention. The arrival of 3I/Atlas, with its strange trajectory, unusual rotation, and anomalous properties, fits seamlessly into this long lineage of mysterious visitors, reinforcing the perception that its appearance was not just accidental but potentially meaningful. Historical records reveal that comets were among the most feared and scrutinized celestial phenomena. In ancient China, meticulous astronomical records documented comets as harbingers of political upheaval or natural disaster. The appearance of a long-tailed comet could precipitate anxiety in courts and among populations, prompting rituals or sacrifices intended to avert the perceived threat. Similarly, European chroniclers in the Middle Ages often recorded cometary appearances alongside plagues, wars, or other societal upheavals, creating a pattern in collective memory that linked celestial anomalies with terrestrial consequences. 3I/Atlas, though scientifically distinct from comets, evokes a parallel psychological response. An object entering the solar system with unusual properties and an unpredictable path, prompting both curiosity and apprehension. The psychological resonance of historical omens is amplified by the object's unusual behavior. Unlike ordinary comets, whose parabolic or elliptical orbits could be calculated and predicted with reasonable precision, 3I/Atlas has consistently defied expectation, displaying trajectory deviations and rotational anomalies that suggest deliberate influence. Ancient observers would have viewed such unpredictability as a sign of agency, a message encoded in the heavens to be deciphered. In a modern context, this unpredictability generates a parallel mixture of wonder and unease, echoing centuries of human experience in which celestial anomalies were interpreted as indicators of change, warning, or opportunity. Other historical interstellar events provide striking points of comparison. Oumuamua, the first confirmed interstellar object observed in 2017, sparked intense debate over whether its elongated shape and unexplained acceleration indicated natural formation or artificial origin. While the scientific community remained divided, the cultural response mirrored historical reactions to celestial anomalies: fascination, speculation, and apprehension. 3I/Atlas amplifies this pattern, presenting even more pronounced anomalies that challenge existing models of physics, composition, and trajectory. The layering of these events across time underscores a continuity in human perception. Objects arriving from beyond the familiar solar system are often interpreted as meaningful or portentous, whether through scientific, cultural, or spiritual frameworks. Legends and myths further illustrate this connection. In many traditions, celestial visitors were not merely atmospheric curiosities but active participants in cosmic narratives. In Norse mythology, for instance, unexpected lights in the sky were associated with omens preceding Ragnarok, the end of the world. Similarly, Native American and Aboriginal traditions often linked comets or unusual meteors to cycles of transformation or spiritual warning. These myths encode a persistent pattern. Human beings interpret anomalous arrivals from the heavens as carriers of significance, whether cautionary or revelatory. The arrival of 3I/Atlas resonates with these narratives, suggesting that the human impulse to assign meaning to unusual cosmic visitors remains as relevant today as it was centuries ago. Historical parallels also emerge in the realm of scientific observation. The 1882 appearance of the Great Comet, for example, coincided with advances in telescopic technology, enabling unprecedented study and documentation. While contemporary observers framed their discoveries within emerging scientific paradigms, cultural and political reactions remained suffused with superstition and apprehension. In this sense, 3I/Atlas mirrors both the technical and psychological dimensions of past events. It is a phenomenon that demands rigorous observation while simultaneously challenging the cultural and cognitive frameworks through which we interpret the unknown. The object's anomalous properties, unusual rotation, reflective variability, and trajectory irregularities invite comparisons with these historical intersections of observation, interpretation, and foreboding. Patterns in timing, recurrence, and visibility amplify the sense of potential warning. Historical events often cluster around periods of significant celestial activity, with repeated anomalous sightings prompting interpretations of continuity or design. 3I/Atlas's sudden appearance in a well-observed region of the sky, combined with its distinctive and unpredictable behavior, mirrors this historical pattern. Though the physical mechanisms may differ, the psychological and narrative parallels are striking. Observers, confronted with a mysterious interstellar arrival, respond by searching for meaning, detecting patterns, and speculating about intent. This process of pattern recognition, innate to human cognition, connects the object to a long lineage of cosmic events interpreted as messages, omens, or catalysts for reflection. Even in cases where historical interpretations were later revised through scientific understanding, the original impact remains significant. The supernova of 1054, visible even in daylight for weeks, was recorded by Chinese, Islamic, and indigenous American observers alike. Initially imbued with spiritual or political significance, it is now understood as a stellar explosion producing the Crab Nebula. Yet the historical records persist, demonstrating that the arrival of an extraordinary celestial event leaves a lasting imprint on human consciousness. Similarly, 3I/Atlas, regardless of whether its origin is natural or artificial, has already shaped contemporary observation, discourse, and speculation, embedding itself within the cultural and scientific landscape in ways that echo these historical precedents. The resonance between 3I/Atlas and historical astronomical events is further underscored by its capacity to inspire interdisciplinary inquiry. Historians, mythologists, and anthropologists can trace patterns of interpretation, while astronomers, physicists, and engineers grapple with the object's physical anomalies. The convergence of cultural memory and scientific investigation generates a layered understanding in which the object serves both as a literal interstellar visitor and a symbolic continuation of humanity's long-standing engagement with the unknown. This duality reinforces the impression that 3I/Atlas may carry significance beyond immediate observation, potentially functioning as a modern echo of historical omens. The possibility of warning or purpose emerges naturally from these historical parallels. Many anomalous celestial events were interpreted as signals requiring action, whether spiritual, societal, or practical. 3I/Atlas's trajectory, irregular rotation, and reflective patterns suggest, at the very least, that it is not indifferent to observation. While contemporary observers cannot definitively assign intentionality, the accumulation of anomalies evokes the historical pattern of celestial phenomena, conveying messages or serving as indicators of change. This connection provides a narrative continuity, bridging the ancient interpretation of skyborne omens with modern scientific and cultural engagement. Finally, the historical lens emphasizes the enduring tension between fear, curiosity, and knowledge. Just as past societies oscillated between superstition and emerging scientific explanation, contemporary observers must balance empirical investigation with acknowledgement of uncertainty. The arrival of 3I/Atlas, with its complex behaviors and mysterious properties, epitomizes this dynamic. It is at once a challenge to scientific understanding, a stimulus for speculation, and a potential harbinger, whether literal or symbolic. The patterns identified in historical events, the interpretation of anomalous objects as warnings, the cultural imprint of cosmic arrivals, and the blending of observation with narrative meaning, provide a compelling framework through which to situate the current phenomenon, creating continuity between history, myth, and the ongoing investigation of the unknown. The arrival of 3I/Atlas, already extraordinary in terms of behavior and potential origin, naturally provoked questions not only about its nature, but also about its possible impact on Earth and human civilization. As the object traversed the solar system, scientists, analysts, and theorists began to explore worst-case scenarios, imagining what might happen if 3I/Atlas carried threats of biological, technological, or energetic nature. The potential consequences extended far beyond scientific curiosity, encompassing geopolitical, environmental, and social ramifications that could reverberate across the globe. One of the first areas of concern was biological risk. While no evidence has yet suggested that 3I/Atlas harbors life, either microbial or otherwise, the theoretical possibility cannot be entirely dismissed. Throughout history, humans have grappled with the introduction of novel biological agents, often with catastrophic consequences. The Black Death, the influenza pandemics of the 20th century, and more recent outbreaks like COVID-19 illustrate how rapidly microorganisms can spread and how unprepared societies can be for new pathogens. In the context of 3I/Atlas, the object's interstellar origin raises the possibility of entirely unfamiliar biochemical structures, potentially capable of interacting with terrestrial biology in unpredictable ways. Even a microbe harmless in its native environment could, theoretically, trigger a cascade of ecological or epidemiological consequences if introduced into Earth's biosphere. Beyond biological concerns, technological threats have been a focus of intense speculation. If 3I/Atlas is indeed an engineered probe, as some researchers and theorists suggest, it could contain technologies capable of remote manipulation, energy emission, or even targeted intervention. Advanced civilizations, if responsible for sending such probes, might employ mechanisms that are incomprehensible to contemporary science. Hypothetical risks include the release of high-energy radiation, directed electromagnetic pulses, or self-replicating nanostructures designed to perform observational or manipulative tasks. Even in the absence of hostile intent, the mere presence of such technologies, uncontrolled and poorly understood, could pose significant hazards to satellites, communication networks, and electrical infrastructure, compounding the potential global impact. Energetic threats also demand careful consideration. 3I/Atlas's reflective properties and anomalous electromagnetic fluctuations suggest it could be capable of storing or transmitting energy in unconventional ways. While no concrete evidence indicates that the object is actively emitting harmful energy, the theoretical possibility of accidental discharge, resonance with terrestrial fields, or interaction with solar activity cannot be dismissed entirely. Scientists modeling these scenarios employ advanced simulations, factoring in orbital dynamics, rotation, and electromagnetic characteristics to assess the range of plausible outcomes. These models, while necessarily speculative, indicate that even minor energetic emissions could have disproportionately large effects if coincident with critical infrastructure or atmospheric conditions. The implications of a direct threat extend naturally into geopolitical territory. Nations around the world monitor near-Earth objects for potential collision risks, and the emergence of an interstellar visitor adds a layer of complexity. Governments must balance transparency with national security, deciding how much information to share publicly while coordinating responses to hypothetical hazards. International cooperation is complicated by the strategic value of advanced technology, potential intelligence about alien capabilities, and the societal consequences of public panic. In such a scenario, even the suggestion of a threat could alter defense postures, trigger emergency preparedness measures, and influence global diplomacy, illustrating the profound ripple effects that a single celestial object can generate. Simulations conducted by aerospace agencies and independent researchers underscore these stakes. Computational models explore a range of contingencies, from harmless flybys to catastrophic impact scenarios. Even if 3I/Atlas were to pass without physical collision, simulations consider secondary effects, including gravitational perturbations of smaller bodies, atmospheric interactions if debris were ejected, and the influence of its energy emissions on near-Earth satellites. In worst-case modeling, analysts examine scenarios in which engineered mechanisms within the object activate unintentionally, whether due to solar exposure, magnetic interactions, or rotational dynamics. While these events remain highly improbable, the potential severity ensures that they cannot be ignored, prompting careful observation and contingency planning. Social ramifications are equally significant. Public awareness of 3I/Atlas's anomalies and the potential for intelligent origin generates both fascination and fear. Historically, perceived extraterrestrial threats have catalyzed cultural, religious, and philosophical reactions, ranging from scientific mobilization to apocalyptic speculation. The combination of uncertainty and potential risk amplifies anxiety, creating conditions in which misinformation, conspiracy theories, and mass hysteria could proliferate. Governments and scientific institutions must navigate a delicate balance, providing sufficient transparency to maintain credibility while avoiding sensationalism that could exacerbate societal stress. Communication strategy, therefore, becomes a critical aspect of risk management, with implications as tangible as the object's physical or technological properties. Historical examples illustrate the complex interplay between real and perceived threats. The appearance of comets in medieval Europe often coincided with social unrest, famine, or disease outbreaks, leading populations to interpret celestial events as portents of doom. While modern societies are more scientifically literate, the psychological impact of unprecedented phenomena persists. 3I/Atlas, with its anomalous behavior and potential artificial origin, triggers a similar cognitive response. Humans instinctively search for patterns, intentions, and warnings. This interpretive process, while culturally and socially meaningful, can exacerbate the perception of risk, influencing policy decisions, media coverage, and individual behavior in ways that extend far beyond the object's physical presence. Experts in planetary defense and aerospace engineering emphasize the importance of proactive preparation. While current observations indicate that 3I/Atlas poses no immediate collision threat, the accumulation of anomalies justifies continued monitoring and simulation. Contingency planning includes evaluating potential trajectories, predicting interactions with solar radiation and magnetic fields, and preparing response protocols in the unlikely event of an impact or energetic discharge. International cooperation is critical, as no single nation possesses the observational resources or technological infrastructure to address an interstellar object comprehensively. Agencies such as NASA, ESA, and JAXA coordinate tracking efforts, share data, and model scenarios to ensure readiness, reflecting a global acknowledgement of the object's potential significance. The prospect of intentional mission-driven behavior adds another layer of urgency. If 3I/Atlas were indeed an advanced probe, questions arise regarding its purpose and potential interaction with Earth. Could it be purely observational, collecting data silently and transmitting information back to its origin? Or might it possess mechanisms for more direct influence, whether through technological means or by deploying secondary instruments? While these ideas remain speculative, they force planners to consider unconventional contingencies, emphasizing that the most severe risks may not be physical collision but the activation of sophisticated, poorly understood mechanisms. Such scenarios challenge traditional risk assessment frameworks, demanding both imagination and rigor in modeling outcomes. Geopolitical considerations extend into areas of resource allocation, defense strategy, and technological preparedness. Nations may invest in additional telescopes, monitoring satellites, or early warning systems to detect and track anomalies in real time. Coordination with military and civil defense agencies ensures that any unexpected energetic or technological events can be addressed promptly. At the same time, disclosure strategies must navigate international diplomacy, balancing transparency with the strategic implications of revealing advanced observational capabilities or the potential presence of alien technology. The convergence of scientific, political, and societal factors illustrates the uniquely complex nature of the threat landscape associated with 3I/Atlas. Environmental considerations, while often overlooked, also merit attention. Even in the absence of direct impact, 3I/Atlas's interactions with solar radiation, magnetic fields, or near-Earth objects could induce subtle environmental changes. Energetic emissions might influence the ionosphere or magnetosphere, while microdebris or volatile compounds could contribute to atmospheric perturbations. Scientists model these possibilities using high-fidelity simulations, factoring in variables such as orbital velocity, rotation, and material composition. While the probability of significant environmental disruption is low, the potential consequences are sufficient to warrant careful observation and continuous reassessment. Public perception, influenced by both media and social networks, amplifies the urgency of preparedness. Coverage emphasizing anomalies, potential artificial origin, or worst-case scenarios generates heightened awareness and, occasionally, fear. Social scientists note that uncertainty is a primary driver of public concern. The less information available, the greater the perceived threat. In the case of 3I/Atlas, partial data releases, conflicting reports, and the object's genuinely unusual behavior create a feedback loop in which speculation intensifies attention, driving both scientific inquiry and societal anxiety. Effective communication strategies are essential to manage these dynamics, balancing transparency with caution to prevent panic while maintaining credibility. Expert opinion continues to diverge on the likelihood of tangible risk. Planetary scientists and aerospace engineers generally agree that the probability of a catastrophic event remains extremely low, emphasizing that the object is traversing a predictable path and poses no immediate collision threat. Yet the unique characteristics of 3I/Atlas, its anomalous rotation, reflective properties, and trajectory deviations, require vigilance. Specialists in risk assessment, planetary defense, and interstellar studies advocate for scenario modeling, continuous observation, and the preparation of contingency protocols to mitigate even the most improbable outcomes. These efforts underscore the balance between rational assessment and preparedness, reflecting a comprehensive approach to managing uncertainty. Speculative predictions, while necessarily hypothetical, illustrate the range of potential implications. In a best-case scenario, 3I/Atlas passes through the solar system harmlessly, providing unprecedented opportunities for scientific study and insight into interstellar phenomena. In a moderate-risk scenario, minor energetic or technological interactions could disrupt communications, satellites, or localized power grids, requiring rapid response but causing no lasting harm. In a worst-case scenario, the activation of advanced mechanisms, introduction of foreign biological agents, or energetic discharge could have global consequences, necessitating international coordination, rapid mitigation, and long-term monitoring. While probabilities differ widely across these scenarios, the mere presence of these possibilities heightens the perception of urgency and reinforces the object's significance. Ultimately, the analysis of potential threats and global implications highlights the complex interplay between physical behavior, technological speculation, and human response. 3I/Atlas is not merely a scientific curiosity. It represents a nexus of possibility, uncertainty, and consequence. Its anomalous characteristics provoke inquiry into physics, engineering, and interstellar dynamics, while simultaneously raising profound questions about security, preparedness, and the human capacity to respond to phenomena that lie beyond direct control. The convergence of worst-case scenarios, expert simulations, and societal impact underscores the profound stakes involved, creating a narrative that is both scientifically compelling and culturally resonant. In conclusion, 3I/Atlas exemplifies the dual nature of extraordinary celestial events. It is both an object of study and a symbol of uncertainty. The potential threats, biological, technological, energetic, are balanced against the low probability of catastrophic outcomes. Yet the consequences of even minor anomalies could be significant, spanning environmental, social, and geopolitical domains. The ongoing analysis, modeling, and monitoring of the object reflect humanity's recognition of both its vulnerability and its curiosity, highlighting the necessity of vigilance, interdisciplinary collaboration, and careful communication. The arrival of 3I/Atlas, in this context, serves as a stark reminder that the universe is not merely a backdrop for observation, but an arena in which extraordinary phenomena challenge understanding, preparedness, and imagination. The possibility that 3I/Atlas carries a secret mission directed toward Earth has captured the imagination of scientists, theorists, and even the general public, merging the observable anomalies with layers of speculation about intent and purpose. Building on its unusual behavior, anomalous rotation, reflective variability, and potential artificial origin, some researchers propose that this interstellar object is far more than a passive visitor. It may be an emissary from an advanced civilization, targeting Earth with a deliberate and potentially terrifying mission. The hypothesis, while speculative, draws strength from the cumulative irregularities observed in its trajectory, composition, and movement, suggesting that there may be a method to what initially appears as randomness. The first clue in support of the secret mission hypothesis is the object's precise trajectory through the solar system. Unlike natural interstellar objects, which generally follow hyperbolic paths determined largely by gravitational forces, 3I/Atlas exhibits subtle but significant deviations that indicate a controlled or semi-controlled course. Detailed calculations suggest that these deviations are not random perturbations caused by solar radiation pressure or gravitational interactions with planets. Instead, they appear consistent with intentional adjustments, potentially designed to bring the object into optimal observational positions relative to Earth, the Sun, or other planets. This deliberate trajectory control, if confirmed, supports the idea that 3I/Atlas is not a passive wanderer but an entity executing a specific mission plan. Beyond trajectory, rotation, and orientation provide additional evidence of intentionality. Observational data indicate that 3I/Atlas does not simply tumble as most asteroids or comets do. Instead, it rotates irregularly, with periodic changes in orientation that suggest precise alignment with solar radiation or line of sight toward Earth. Some researchers hypothesize that this could serve multiple purposes: optimizing energy absorption, maintaining communication capabilities, or aligning reflective panels to convey signals. Such behavior implies an underlying intelligence or mission-driven design, as natural forces alone would not produce such coordinated orientation changes. These rotational anomalies reinforce the notion that the object may be executing deliberate maneuvers consistent with a directed mission. The object's reflective properties also hint at purposeful function. Spectroscopic analysis reveals alternating regions of high and low reflectivity, irregular metallic surfaces, and unusual chemical compositions. While some anomalies may arise naturally, the pattern and distribution of these reflective zones suggest functionality rather than randomness. Hypotheses include optical signaling, energy modulation, or even the projection of intentional patterns detectable from Earth or space-based observatories. If these reflective characteristics are indeed functional, they imply an intention beyond mere survival, potentially indicating communication, observation, or other mission-related objectives. Scientists exploring the secret mission hypothesis have proposed several potential motives for 3I/Atlas's presence near Earth. Observation is perhaps the most straightforward. The object could serve as a long-duration probe, monitoring Earth, its biosphere, technological development, or electromagnetic activity. Unlike passive observation from a distance, a targeted mission could allow precise data collection over extended periods, facilitated by the object's trajectory adjustments and orientation control. This aligns with the object's anomalous behavior, which could be interpreted as careful positioning to maximize observational efficiency. If 3I/Atlas is monitoring Earth, it may represent the first direct evidence of interstellar intelligence actively surveilling our planet, raising profound implications for both scientific inquiry and global security. Resource extraction is another proposed motive, albeit more speculative. Advanced civilizations, if capable of interstellar travel or probe deployment, may seek to survey planetary systems for materials, energy sources, or other strategic assets. 3I/Atlas could be assessing Earth, its moons, or surrounding asteroids for rare elements, isotopes, or compounds useful for technological applications. Reflective anomalies or electromagnetic emissions might serve as tools for scanning or analysis, analogous to remote sensing used in contemporary space exploration. While this hypothesis is largely conjectural, it cannot be entirely dismissed, particularly given the object's unusual properties and the apparent precision of its maneuvers. A more ominous potential motive involves warning or prelude to invasion. Some theorists suggest that 3I/Atlas may serve as a reconnaissance probe intended to assess Earth's defenses, technological capabilities, or social dynamics prior to a future intervention. While this scenario remains highly speculative and lacks direct evidence, it draws upon the observed anomalies and the possibility of an intelligent origin. The concept of a preemptive observational mission is consistent with known strategies in both human and theoretical extraterrestrial contexts. Understanding a system before engaging is a logical and efficient method of preparation. In this view, the object's approach is not coincidental but strategically designed, with subtle signals encoded in trajectory, rotation, and reflective behavior to maximize information gathering. Analyses of its trajectory relative to planetary alignments add weight to the secret mission hypothesis. By examining orbital calculations, some researchers argue that 3I/Atlas's path is not simply influenced by gravitational forces but appears to exploit planetary positions, solar radiation, and even orbital resonances to maintain a stable, mission-optimal route. Such precision is difficult to reconcile with natural dynamics alone. The patterns suggest a level of foresight and control consistent with advanced engineering or intelligent guidance, bolstering the idea that the object's arrival near Earth is part of a carefully orchestrated plan rather than a chance encounter. The convergence of multiple anomalies, trajectory, rotation, reflectivity, and composition creates a compelling narrative for those investigating the secret mission hypothesis. Each individual anomaly could conceivably be explained by natural forces or measurement error. However, the combination of these irregularities, observed consistently over time, defies simple explanation. In particular, the alignment of trajectory adjustments with rotational patterns, coupled with the irregular yet purposeful reflectivity, suggests an underlying intelligence. This synthesis of evidence forms the backbone of the hypothesis, providing a framework in which intentionality becomes a plausible consideration rather than pure speculation. Experts examining potential mission purposes also consider timescale and duration. Unlike short-lived interstellar encounters, 3I/Atlas appears capable of extended observation or activity, suggesting robust construction and autonomy. Its rotation, reflective properties, and trajectory adjustments indicate not merely passive presence but active function sustained over months or even years. Such endurance implies engineering far beyond human capabilities, consistent with a probe designed for long-term interstellar reconnaissance. The implications are profound. Humanity may be observing an artifact that has traversed vast distances with deliberate intent, challenging assumptions about technological possibilities, interstellar communication, and the potential reach of advanced civilizations. Evidence of anomalies in energy emissions further reinforces the secret mission hypothesis. Observations suggest subtle electromagnetic variations inconsistent with known natural processes, potentially indicative of internal systems or energy management. These emissions may serve multiple functions, powering onboard mechanisms, maintaining communication links, or even scanning Earth's magnetic and technological environment. While none of these functions have been directly confirmed, The consistency of the anomalies over time supports the notion that 3I/Atlas is performing purposeful activity rather than exhibiting random or purely natural behavior. Simulations of hypothetical interactions provide additional insight into the potential mission. Computational models examining energy, trajectory, and reflectivity suggest that small adjustments in orientation could optimize observation or signal transmission. These models demonstrate how seemingly minor rotational variations might have significant functional consequences, particularly if the object is designed for reconnaissance. By comparing natural rotational decay with the observed patterns of 3I/Atlas, researchers highlight the improbability of random alignment, further strengthening the argument for intentional behavior consistent with a mission. Cultural and psychological considerations also intersect with the secret mission hypothesis. Historically, human societies have interpreted anomalous celestial phenomena as messages or portents, suggesting that our response to 3I/Atlas is part of a broader cognitive and cultural pattern. The perception of deliberate observation, combined with uncertainty about potential outcomes, intensifies the psychological impact of the object's presence. This interplay between observation, anomaly, and interpretation mirrors historical responses to comets, meteors, and other rare celestial visitors, creating a narrative in which 3I/Atlas functions as both a literal object and a symbolic harbinger. Alternative interpretations, while less dramatic, remain relevant. Some scientists emphasize that the anomalies could result from previously unobserved natural phenomena, complex material properties, or measurement artifacts. While these explanations may account for individual irregularities, they struggle to reconcile the combination of trajectory precision, rotation anomalies, reflectivity patterns, and potential energy emissions. Consequently, the secret mission hypothesis persists as a framework that accommodates the full spectrum of observed data, providing a cohesive narrative that accounts for both physical and functional anomalies in a manner that natural explanations alone cannot fully address. Political and strategic dimensions further complicate the scenario. If 3I/Atlas is indeed on a mission, the potential implications for global security are profound. Nations monitoring the object must weigh transparency against the risks of panic or misinterpretation, balancing public disclosure with strategic preparedness. Coordinated international observation becomes essential, as no single country possesses the resources to comprehensively monitor or respond to a sophisticated interstellar probe. This global dimension mirrors the challenges faced in historical planetary defense scenarios, amplified by the uncertainties surrounding intelligent origin and potential intent. The potential for future interaction with Earth adds urgency to the analysis. Even if 3I/Atlas is currently non-threatening, its continued presence, maneuverability, and anomalies suggest that it could engage in observation, signaling, or other activities in the future. Strategic planning must therefore consider long-term monitoring, technological countermeasures, and potential mitigation strategies, even in the absence of immediate danger. The object's behavior underscores the necessity of vigilance, adaptive response, and interdisciplinary collaboration among scientists, engineers, policymakers, and security analysts. Finally, the secret mission hypothesis emphasizes the broader philosophical implications of encountering an interstellar probe with potential intent. Humanity is confronted not only with technical and practical challenges but also with questions about its place in the cosmos, the nature of intelligence beyond Earth, and the ethical considerations of observing or interacting with objects whose origins and motives are unknown. The presence of 3I/Atlas invites reflection on both human capability and vulnerability, merging empirical observation with existential inquiry in a manner rarely encountered in contemporary science. The arrival and anomalous behavior of 3I/Atlas created not only scientific curiosity and speculation about a potential secret mission but also a profound challenge in terms of public awareness. The dissemination of information, or lack thereof, has shaped public perception in ways that often diverge sharply from the underlying reality. Observers, both professional and amateur, have relied on a mix of official channels, media reports, and social media commentary to form impressions of the object. Yet, as with many high-profile phenomena, the presentation of information has been selective, fragmented, or manipulated, leading to a complex landscape in which truth, speculation, and sensationalism coexist in uneasy tension. Official channels have historically struggled with balancing transparency and control when addressing extraordinary celestial events. Space agencies, astronomical observatories, and governmental bodies possess the technical expertise to interpret data, but also bear the responsibility of preventing unwarranted panic. In the case of 3I/Atlas, initial announcements were carefully calibrated, emphasizing that the object posed no immediate threat and framing it primarily as a subject of scientific interest. While such statements are accurate insofar as collision risk is concerned, they omit the more unsettling anomalies, unusual rotation, reflective patterns, and trajectory deviations that feed into broader speculation about intelligence or intent. This selective disclosure illustrates the tension between factual reporting and narrative control, a recurring challenge in managing public awareness of extraordinary events. Media outlets, seeking attention and engagement, have often amplified both curiosity and fear. Headlines oscillate between dismissive reassurance and dramatic warnings, reflecting the incentive structure of modern news cycles. Sensational reporting highlights anomalous behavior, raising the specter of extraterrestrial intelligence or imminent threat, while simultaneously presenting statements from authorities to temper public reaction. This duality generates a feedback loop. Audiences are drawn to sensational claims, yet reassured, or sometimes confused, by official disclaimers. The result is a fragmented perception of reality, in which the object's scientific characteristics are often overshadowed by the social dynamics of information dissemination. Social media amplifies these effects exponentially. Platforms designed for rapid sharing and engagement provide fertile ground for speculation, rumor, and conspiracy. Observers with limited technical knowledge interpret anomalies, sometimes reaching conclusions that diverge significantly from scientific consensus. Viral posts, memes, and commentary frequently exaggerate or distort details, transforming minor uncertainties into perceived existential threats. Algorithms favor content that evokes strong emotional responses, meaning that fear-inducing interpretations of 3I/Atlas are disproportionately amplified compared with measured scientific explanations. The result is a collective perception heavily influenced by psychological bias, social reinforcement, and digital echo chambers, complicating efforts to convey accurate information. Psychological factors play a crucial role in shaping public understanding. Humans have an innate tendency to perceive patterns and assign meaning, particularly in response to novel or anomalous stimuli. 3I/Atlas, with its unusual trajectory, rotational anomalies, and reflective properties, triggers precisely this cognitive process. When combined with incomplete information or sensationalized media coverage, these psychological tendencies can amplify perceptions of threat or intelligence. Fear, curiosity, and wonder intertwine, creating a social environment in which speculation about secret missions, alien origins, or covert agendas becomes widespread, often independent of concrete evidence. Historical parallels reinforce this dynamic. Past celestial events, comets, supernovae, and meteors, provoked intense public reaction, frequently characterized by fear, mythologization, or exaggerated claims of significance. While modern societies benefit from scientific literacy and rapid information dissemination, the fundamental psychological response to anomalous celestial phenomena remains consistent. Observers instinctively seek explanation, often defaulting to narratives that emphasize potential danger or intelligence when confronted with unknown objects. 3I/Atlas fits within this historical pattern, illustrating how public perception can diverge from technical reality while remaining deeply meaningful in cultural and social contexts. Media manipulation, whether intentional or inadvertent, further complicates the landscape. News organizations may downplay certain aspects of 3I/Atlas, emphasizing safety and normalcy to prevent panic, while simultaneously highlighting anomalies to attract attention. Governments and institutions may release partial data, selectively emphasizing measurements that support a narrative of control or benign interest. In some cases, leaks or unofficial reports introduce contradictory information, creating confusion and undermining public trust. These dynamics produce a layered narrative environment in which truth, speculation, and intentional messaging intersect, making it difficult for lay audiences to discern the actual state of affairs. Social media networks exacerbate these challenges by enabling rapid proliferation of both accurate and inaccurate information. Viral posts often distill complex phenomena into easily digestible narratives, favoring emotional resonance over factual precision. Conspiracy theories, ranging from claims of hidden extraterrestrial intelligence to secret government cover-ups, gain traction because they offer coherent explanations for otherwise ambiguous observations. The interactive nature of these platforms allows reinforcement through likes, shares, and comments, creating a form of collective validation that further entrenches misinformation or exaggeration. The resulting social perception may bear little resemblance to technical reality, yet exerts tangible influence on public behavior, policy discussions, and even scientific discourse. Professional scientists and communicators face a delicate balancing act. On one hand, they must provide accurate and timely information, contextualizing anomalies in ways that are comprehensible to non-specialists. On the other hand, overemphasis on uncertainty or speculation can inadvertently fuel sensationalist narratives. Communicating the unusual properties of 3I/Atlas, its reflective patterns, rotational anomalies, and trajectory deviations, requires careful phrasing to convey significance without implying imminent danger. This communication challenge is compounded by the decentralized and rapid nature of information flow, in which social media, news outlets, and informal channels operate outside traditional editorial oversight. Simultaneously, the public's demand for narrative coherence influences reporting and commentary. Individuals seek explanations that fit into broader frameworks of understanding, whether technological, extraterrestrial, or conspiratorial. Media outlets and social commentators respond to these demands, framing coverage to maximize engagement and interpretive satisfaction. In doing so, they may inadvertently emphasize fear or mystery over empirical data, further shaping collective perception. This interplay of demand, presentation, and cognitive bias creates a self-reinforcing system, in which societal focus on anomalies and potential threat grows independent of definitive evidence. Contrasts between public perception and reality are especially evident when examining scientific publications versus mainstream reporting. Peer-reviewed studies detail measured observations, uncertainty margins, and potential natural explanations for 3I/Atlas's anomalies. Yet these nuanced discussions often receive limited attention outside academic circles, overshadowed by headlines and social commentary that prioritize dramatic or emotionally compelling narratives. The result is a persistent gap between what is technically known and what is popularly believed, a divergence that complicates policy, education, and public response. The manipulation of information is further evident in selective framing of uncertainty. Media and official statements frequently highlight the object's low probability of collision, emphasizing safety while downplaying anomalous behavior. While intended to prevent panic, this framing can create a false sense of security or suppress legitimate inquiry. Conversely, sensationalized accounts may exaggerate anomalies or suggest intentionality without robust evidence, inflating fear and speculation. The dual pressures of reassurance and engagement create a complex narrative landscape in which the public simultaneously perceives both safety and existential risk, often without reconciling these contradictions. Cultural context also shapes interpretation. In societies with high trust in institutions, official messaging may be accepted with minimal skepticism, reducing the spread of conspiratorial narratives. In contrast, communities with historical distrust of authority may amplify suspicion, interpreting selective disclosures as evidence of hidden agendas. These dynamics intersect with social media amplification, creating geographically and culturally heterogeneous perceptions of 3I/Atlas. Some groups focus on scientific curiosity and exploration, while others emphasize secrecy, threat, or potential alien intent, highlighting the profound variability in societal understanding. The psychology of fear plays a central role in public perception. Humans are predisposed to respond more strongly to potential threats than to neutral or positive stimuli, a phenomenon well documented in behavioral science. 3I/Atlas's anomalous behavior, combined with limited transparency, triggers this response. Even minor uncertainties, such as rotational anomalies or reflective variability, can be interpreted as signs of intentionality or hidden danger. The result is a heightened emotional engagement that colors interpretation, reinforcing sensationalist narratives and shaping social discourse in ways that diverge from empirical assessment. Misinformation and disinformation campaigns further complicate societal understanding. Whether originating from well-intentioned speculation, strategic manipulation, or intentional deception, these campaigns exploit gaps in knowledge, ambiguity, and psychological bias. Viral narratives claiming secret missions, alien intelligence, or government cover-ups intersect with factual reporting in ways that blur boundaries, leaving the public with conflicting signals. This environment creates both opportunity and challenge for scientific communication. Conveying accurate information requires not only technical explanation but also countering persistent myths and distorted interpretations. Education and outreach efforts attempt to bridge this gap. Public lectures, scientific publications, interactive online platforms, and documentary media offer nuanced discussion of 3I/Atlas, emphasizing empirical observation, methodological rigor, and alternative explanations. These initiatives aim to empower individuals with critical thinking tools, helping them navigate the intersection of anomaly, speculation, and media framing. Yet the effectiveness of such outreach is often limited by the speed and emotional resonance of viral content, demonstrating the persistent tension between reasoned analysis and sensationalized perception. Ultimately, the story of 3I/Atlas in public awareness is not merely about the object itself but about the complex dynamics of information control, media manipulation, and cognitive psychology. The contrast between what is technically known, what is selectively disclosed, and what is sensationalized creates a landscape in which truth is layered, contested, and mediated by both institutional authority and popular interpretation. This interplay illustrates how societal effects extend beyond scientific observation, shaping perceptions, responses, and discourse in ways that are both subtle and profound. As the public grappled with the mysteries of 3I/Atlas and navigated the often conflicting narratives presented by media and official channels, a parallel discourse emerged within the scientific community. While mainstream organizations emphasized natural explanations and dismissed extreme speculation, a growing number of independent researchers and astronomers began to speak out, offering alternative interpretations that challenged conventional wisdom. Their observations, analyses, and warnings highlighted both the unusual characteristics of the object and the difficulties inherent in assessing phenomena that might straddle the line between natural occurrence and potential intelligence. Dr. Elena Vasquez, an astrophysicist with extensive experience in interstellar object tracking, became one of the first to publicly voice concern about 3I/Atlas's anomalies. In a carefully worded interview, she noted, "While many colleagues are content to categorize this as another interstellar asteroid, the rotation patterns, reflective variability, and trajectory deviations cannot be fully explained by natural forces alone. There is a possibility, however remote, that we are observing an artifact with some form of controlled behavior." Her statement, though cautious, drew immediate attention. It was unusual for a professional scientist to entertain the notion of deliberate design, yet the observational evidence made a compelling case for further scrutiny. Independent researchers also emphasized the limitations imposed by institutional conservatism. Many scientists working within governmental or international space agencies face implicit pressure to conform to widely accepted explanations. Challenging the consensus, particularly with suggestions of intelligent origin or mission-driven behavior, risks professional marginalization, reduced funding opportunities, and public skepticism. Dr. Vasquez herself reported that initial attempts to publish detailed findings on 3I/Atlas were met with resistance, reviewers insisting that natural explanations must be assumed unless irrefutable proof exists. This resistance underscores the tension between scientific caution and the necessity of addressing anomalous data openly. Other astronomers echoed similar concerns, often highlighting subtle but persistent irregularities. Professor Malik Chun, an expert in orbital dynamics, commented, "The object's trajectory adjustments appear too precise to be entirely natural. Even accounting for gravitational interactions and radiation pressure, there are deviations that suggest intentional control. While we cannot confirm intelligence, these deviations warrant serious investigation rather than dismissal." His careful phrasing reflects both the need for scientific rigor and the inherent suspense in confronting potentially paradigm-shifting evidence. Interviews with amateur astronomers who first observed unusual signals from 3I/Atlas also contribute to the broader narrative. These observers often operate outside formal institutional frameworks, allowing them to highlight anomalies without the same professional constraints. Many report irregular brightness fluctuations, unexpected rotation rates, and inconsistent spectral signatures. When combined with the observations of professional astronomers, these reports create a multi-layered picture, an object that defies straightforward categorization and challenges prevailing assumptions about interstellar visitors. Warnings issued by these independent voices are tempered by acknowledgement of uncertainty. Scientists are careful to distinguish between speculation and evidence, emphasizing the need for continued observation and modeling. For example, Dr. Vasquez cautioned, "We cannot assert definitively that 3I/Atlas is a probe or intelligent artifact. What we can say is that its behavior is anomalous, and the possibility of artificial design cannot be entirely ruled out. Ignoring these anomalies could leave us unprepared for consequences we cannot yet foresee." This nuanced stance balances credibility with suspense, inviting both professional scrutiny and public attention without resorting to sensationalism. The credibility of dissenting voices is further reinforced by peer-reviewed analyses of trajectory, rotation, and reflectivity. Publications in specialized journals document measurements that deviate from predicted natural models, highlighting rotational stabilization, reflective modulation, and unexplained energy signatures. While these papers often stop short of asserting intentionality, they provide empirical grounding for hypotheses that extend beyond standard classifications. The rigorous methodology employed by these researchers bolsters their authority, demonstrating that concern is not based on conjecture alone, but on carefully gathered and analyzed data. Resistance within the scientific community remains a significant factor. Colleagues adhering to conventional paradigms often view claims of potential intelligence or mission-driven behavior as fringe science. This skepticism is both protective, ensuring adherence to empirical standards, and conservative, potentially discouraging exploration of extraordinary possibilities. Scientists who speak out about 3I/Atlas navigate a delicate path, balancing evidence-based caution with the desire to explore what may be unprecedented phenomena. The tension between maintaining credibility and advocating for further investigation defines much of the discourse surrounding the object. Despite these challenges, the voices of independent researchers have influenced institutional approaches. Space agencies and observatories, while publicly emphasizing natural explanations, have quietly expanded observation schedules, enhanced spectral analysis, and increased monitoring of rotational anomalies. The recognition that independent analyses raise legitimate questions has created an environment in which extraordinary claims are not dismissed outright but are incorporated into ongoing research frameworks. In this sense, dissenting voices have shaped the scientific response indirectly, guiding priorities and resource allocation even in the face of official conservatism. Interviews with interdisciplinary experts further underscore the significance of anomaly-focused investigation. Planetary scientists, engineers, and theoretical physicists contribute diverse perspectives, examining energy emissions, potential artificial mechanisms, and long-duration trajectory stability. These analyses, while often speculative, provide frameworks for evaluating the broader implications of 3I/Atlas's behavior. When combined with astronomical observations, they suggest that the object may warrant consideration as a probe or mission-driven entity, even if definitive proof remains elusive. The interplay between credibility and caution is evident in public statements. Researchers speaking out must carefully qualify their assessments to avoid being misinterpreted as sensationalists. Phrases such as "cannot rule out," "anomalous behavior observed," and "further investigation warranted" are common, reflecting both the empirical constraints of the data and the stakes of public communication. This careful rhetoric allows scientists to maintain authority while still drawing attention to irregularities that could have profound implications if interpreted as evidence of intelligent origin or intentional mission. Historical parallels provide additional context for these dynamics. Similar tensions arose during the early observations of interstellar objects like Oumuamua, where initial speculation about artificial origin sparked intense debate. Over time, the scientific process refined understanding, but the early discourse highlighted the challenges faced by researchers who identify anomalies that suggest possibilities beyond conventional models. 3I/Atlas has rekindled this dynamic, forcing scientists to navigate between professional caution, empirical rigor, and the potential need for paradigm-challenging explanations. In conclusion, the voices of independent researchers and astronomers speaking out about 3I/Atlas provide both credibility and suspense. Their observations, analyses, and warnings highlight the object's anomalous behavior, suggesting that it may be more than a natural interstellar visitor. At the same time, they navigate resistance from mainstream institutions and the broader scientific community, emphasizing caution while advocating for continued investigation. By documenting deviations in trajectory, rotation, and reflectivity, these scientists create a compelling, evidence-based foundation for considering extraordinary possibilities, bridging empirical observation and the profound uncertainty that defines humanity's encounter with the unknown. As the observations of 3I/Atlas accumulate and the voices of both cautious and dissenting scientists grow louder, the question naturally arises: what lies ahead? The future of this interstellar enigma is uncertain, and projections must navigate a delicate balance between empirical observation, predictive modeling, and informed speculation. Based on the data collected thus far, scientists are preparing for a spectrum of potential scenarios, ranging from continued passive observation to more interactive or even transformative encounters with our solar system. Each possibility carries distinct scientific, technological, and societal implications, demanding careful consideration. Trajectory analyses remain central to understanding what might happen next. While current models suggest that 3I/Atlas will continue its hyperbolic path through the solar system, subtle deviations in orientation and rotation could lead to unexpected interactions with planetary bodies, radiation belts, or even artificial satellites. Astrodynamic simulations take into account gravitational perturbations from planets, solar radiation pressure, and other minor forces, but they also allow for the consideration of deliberate course adjustments should the object exhibit signs of autonomous control. These simulations, while inherently speculative regarding intentionality, help establish boundaries for potential encounters, informing both scientific research and strategic preparedness. One area of particular focus involves Earth itself. Although the object currently poses no collision threat, its proximity offers unprecedented opportunities for high-resolution observation. Scientists are exploring possibilities for both passive and active engagement. Passive monitoring includes continued tracking of trajectory, rotation, reflectivity, and energy emissions. Active engagement, while speculative, might involve coordinated radar or laser illumination to gather additional data about composition and structure. Such measures could reveal whether anomalies observed to date are consistent with natural processes or suggest a more deliberate, engineered purpose. The choice of approach is critical, as overly aggressive probing might provoke unintended consequences, while insufficient observation risks missing crucial signals. Another consideration is the potential for technological or biological interaction. While the probability of direct threat remains low, scenarios involving energy emissions, unknown materials, or even subtle information transfer are not entirely dismissible. Researchers model these possibilities to assess risk, explore detection methods, and develop contingency plans. For example, if reflective surfaces are designed to encode information, monitoring changes in intensity or spectral characteristics could yield insights into intended communication. If energy fluctuations correlate with solar exposure or alignment with Earth, it may indicate internal power systems or sensors operating autonomously. Each anomaly thus becomes a critical data point in constructing predictive models of future behavior. Speculation about intelligent origin drives some of the more provocative predictions. If 3I/Atlas is indeed a probe from an advanced civilization, its continued journey could involve adaptive responses to Earth's technological or electromagnetic signals. This hypothesis, while unconfirmed, leads to the notion that the object may be capable of dynamically adjusting its trajectory, orientation, or reflective behavior in response to observations. Such adaptability would fundamentally alter the expected timeline of events, introducing a level of unpredictability that challenges traditional modeling techniques. Consequently, researchers must consider not only physical interactions but also the potential for informational or observational reciprocity. The social and psychological dimensions of future developments are equally significant. Public interest in 3I/Atlas has already demonstrated how anomalies, media coverage, and scientific communication interact to shape perception. Continued anomalies or unexpected behaviors could amplify fear, curiosity, or both, depending on how information is framed. Social scientists and communicators are therefore developing strategies for transparent reporting, educational outreach, and measured guidance to ensure that society remains informed without succumbing to panic or disinformation. Lessons from past interstellar phenomena, such as the early excitement surrounding Oumuamua, inform these strategies, emphasizing clarity, context, and iterative communication. Global coordination will play an essential role in future observation and response. Multiple space agencies, research institutions, and amateur networks contribute to a decentralized but interconnected monitoring infrastructure. By sharing observations, refining predictive models, and coordinating measurement strategies, the international community can collectively increase situational awareness. This collaborative approach is vital, as no single entity possesses the observational bandwidth, computational resources, or interpretive expertise required to fully anticipate the object's behavior. Moreover, cross-disciplinary collaboration, combining astrophysics, engineering, planetary defense, and social science, is necessary to address the multifaceted challenges posed by potential anomalies or deliberate mission activity. Long-term predictions also consider the broader solar system environment. Interactions with planetary magnetic fields, solar wind, and micrometeoroid populations could subtly influence trajectory, rotation, or energy emission patterns. Continuous monitoring will help determine whether observed changes are consistent with natural environmental effects or suggest autonomous adjustment by the object. For instance, periodic deviations from predicted hyperbolic paths could indicate propulsion-like behavior or energy modulation. Researchers are particularly attentive to such deviations because they may provide indirect evidence of mission-driven activity, even in the absence of direct communication or observable structure. Speculative scenarios extend to potential communication attempts. While no definitive signal has been detected, the combination of rotational modulation, reflective anomalies, and periodic energy fluctuations provides a theoretical basis for considering encoded messages. If 3I/Atlas is designed for long-duration observation or data relay, subtle adjustments in reflectivity or emission patterns could serve as a form of contact. Scientists are exploring signal processing techniques capable of detecting low-intensity or non-conventional modulations, recognizing that conventional electromagnetic monitoring may miss non-standard methods of information transfer. Preparing for such possibilities requires both technological investment and conceptual openness. Humanity's preparedness for future encounters involves more than observation. It encompasses strategic planning, technological readiness, and societal resilience. Contingency measures include expanded telescopic surveillance, enhanced radar and spectral monitoring, and simulation of hypothetical interactions. Governments and research institutions are increasingly aware of the need to plan for anomalous objects whose behavior may not conform to classical astrophysical expectations. This planning extends to communication strategies, public education, and cross-border collaboration, emphasizing the dual objectives of maximizing scientific insight while minimizing societal disruption. The unpredictable nature of 3I/Atlas ensures that speculation remains a necessary component of preparedness. Researchers model a range of trajectories, potential rotational behaviors, and reflective anomalies to assess plausible outcomes. Worst-case scenarios, though statistically unlikely, are incorporated into planning to ensure comprehensive readiness. These include close flybys that may impact satellites or atmospheric observations, sudden energy emissions, or changes in trajectory that alter observational windows. By preparing for both likely and extreme contingencies, scientists and policymakers create a robust framework capable of accommodating emerging data without succumbing to panic. Technological advances in observation are central to refining predictions. Improvements in high-resolution imaging, spectroscopic analysis, and energy detection allow unprecedented insight into the physical and functional characteristics of 3I/Atlas. In parallel, machine learning algorithms analyze massive datasets for patterns that may elude human observers, identifying correlations between rotation, reflectivity, and energy emissions. These tools enhance predictive capabilities, enabling researchers to update models dynamically as new data becomes available. The interplay of observation, computation, and theory thus forms the backbone of forward-looking strategies. Beyond the scientific and technological, philosophical considerations also shape projections. Encountering an object of uncertain origin and potential intelligence challenges assumptions about humanity's uniqueness, technological maturity, and role in the cosmos. Predictions are therefore not purely operational but also reflective, inviting contemplation of ethical, cultural, and existential questions. How should humanity respond to a potentially intelligent visitor? What obligations exist in terms of observation, interaction, or restraint? These questions underscore that predictions are intertwined with values, not only physics, shaping the ways society may react to whatever unfolds. Finally, the continued study of 3I/Atlas will shape our understanding of interstellar phenomena for generations. Each observation, anomaly, and hypothesis contributes to a richer understanding of what is possible beyond our solar system. While uncertainty dominates, the combination of careful observation, scientific rigor, and informed speculation ensures that humanity is not merely passive in the face of this enigmatic object. Instead, we actively interpret, predict, and prepare, balancing empirical analysis with imaginative exploration, fully aware that the future of 3I/Atlas, and perhaps of human understanding itself, remains unwritten. As the chronicle of 3I/Atlas unfolds, the cumulative weight of observation, analysis, and speculation points to an unsettling conclusion. This is no ordinary interstellar visitor. From the first discovery, through the careful tracking of anomalous behaviors, to the dissenting voices of independent scientists, a pattern emerges that suggests the presence of a purpose beyond random cosmic drift. The evidence does not definitively confirm intelligence or intent, yet the combination of trajectory irregularities, reflective anomalies, rotational stability, and subtle energy emissions presents a scenario that cannot be dismissed lightly. Humanity, observing from the vantage of Earth, finds itself in the position of witness to a phenomenon that challenges assumptions, tests preparedness, and sparks both awe and fear. Early observations revealed what initially seemed to be a minor curiosity, an interstellar object moving along a hyperbolic trajectory, briefly visible against the backdrop of stars. But as data accumulated, small anomalies grew too significant to ignore. Scientists noted deviations from predicted paths, unexpected rotation patterns, and periodic reflective fluctuations inconsistent with natural explanations. While conventional astrophysical models offered plausible hypotheses, the persistence and coherence of these anomalies prompted some to entertain more provocative possibilities. Could these deviations signify deliberate navigation or an encoded message? Were they the signature of an advanced probe observing or testing humanity? Each question deepened the sense of suspense, layering uncertainty over scientific inquiry. Concurrently, the interplay of secrecy and selective disclosure amplified the tension. Government agencies, space observatories, and scientific institutions balanced transparency with caution, releasing only fragments of data while emphasizing safety and routine interest. Leaks, unofficial statements, and partial reports suggested that the anomalies were not entirely understood, or perhaps that they were being deliberately withheld from public scrutiny. This discrepancy between public information and internal awareness fueled speculation, reinforcing the narrative that 3I/Atlas might carry a mission or intelligence beyond our comprehension. In this context, secrecy itself became a variable in understanding the object, a silent force shaping perception and amplifying unease. Independent scientists, emboldened by observational anomalies, added layers of credibility and urgency. Their warnings, while careful to avoid sensationalism, highlighted behaviors that challenged naturalistic assumptions. Trajectory adjustments, reflective modulation, and rotational stability suggested that the object might not be a passive wanderer. Instead, these features could indicate intentional design, optimized for observation, information relay, or even a directed approach toward the solar system. The resistance they faced within mainstream institutions underscores the tension inherent in acknowledging potential extraterrestrial agency. The boundary between rigorous skepticism and open consideration of unprecedented phenomena is both professional and existential. Historical parallels illuminate the psychological and cultural dimensions of this encounter. Humanity has long interpreted celestial events, comets, meteors, supernovae, as omens, warnings, or signs of transformative change. While modern science situates 3I/Atlas within measurable parameters, the collective imagination continues to respond to the unknown with a mixture of fear, curiosity, and awe. This resonance between past and present reinforces the narrative that the object could serve as both observer and harbinger. Each anomaly, each unexplained fluctuation, echoes earlier patterns of cosmic phenomena interpreted as portents, subtly heightening the perception that 3I/Atlas carries an intentional, possibly alarming purpose. Theoretical and speculative models deepen the sense of potential threat. Scenarios range from passive surveillance to active intervention, encompassing possibilities of energy emissions, encoded signals, or technological manipulation. While the likelihood of immediate danger remains low, the mere existence of these possibilities forces a reevaluation of humanity's vulnerability. Earth is technologically advanced yet spatially unprotected, culturally diverse yet collectively inexperienced in responding to non-terrestrial agency. The combination of anomalous evidence and speculative threat highlights both the object's enigmatic nature and the strategic imperative for observation, preparation, and caution. Public awareness and media portrayal have amplified the psychological impact of these developments. Sensationalist narratives, social media speculation, and contrasting official statements create an environment in which the mysterious qualities of 3I/Atlas are magnified. Fear, fascination, and curiosity coexist, often in tension, producing a societal engagement that is as complex as the object itself. In this sense, the human response becomes an integral part of the narrative. Perception, interpretation, and communication shape not only understanding but also preparedness. How humanity reacts to anomalies, conflicting information, and potential risk may influence the trajectory of both knowledge and consequence. Looking forward, predictions remain uncertain, but preparation is possible. Observational networks are expanding, computational models are refined, and interdisciplinary collaboration is increasing. Scientists anticipate continued monitoring of trajectory deviations, rotational patterns, and reflective anomalies, while maintaining awareness of the potential for adaptive or intelligent behavior. Contingency planning, public communication strategies, and global coordination ensure that humanity is not entirely passive in the face of the unknown. Yet the fundamental uncertainty persists. 3I/Atlas remains a traveler from beyond, unpredictable, silent, and possibly purposeful, challenging the limits of observation, understanding, and imagination. The convergence of evidence, expert warning, historical resonance, and public engagement crystallizes the core narrative. 3I/Atlas may embody a terrifying mission. Whether the purpose is observation, assessment, subtle warning, or preparation for future interaction, the possibility demands attention. Humanity is both witness and participant, dependent on observation, reasoning, and collaboration to anticipate what may unfold. The combination of unexplained anomalies, selective disclosure, and cautious scientific speculation underscores that the story is ongoing, incomplete, and laden with uncertainty. Ultimately, the conclusion does not offer certainty but rather a framework for contemplation. Humanity is confronted with a phenomenon that transcends ordinary classification, revealing both the vulnerabilities and capabilities of our species. Observation, analysis, and preparation become acts of survival and curiosity simultaneously. In facing 3I/Atlas, we confront the limits of our understanding, the bounds of our technology, and the profound question of whether we are being watched, tested, or subtly influenced by forces beyond Earth. The chilling possibility remains that the object's trajectory, behavior, and anomalies are not random, but intentional, part of a mission whose details remain hidden, yet whose presence is unmistakable. And as we continue to monitor, calculate, and speculate, one question lingers more persistently than any trajectory plot or spectral reading. If 3I/Atlas is indeed a deliberate probe or harbinger, what exactly is it waiting for, and how close are we to the moment when its true mission is revealed? This final, unanswered question keeps the mystery alive, ensuring that the story of 3I/Atlas remains both an urgent scientific inquiry and a haunting narrative of potential cosmic intent.